All right, all. Let's chat about a new topic today. So last week we went over the concepts of raster graphics. Raster graphics being the idea that we are dealing with images built with pixels. Okay. And so that would be like programs like that we went over, like Adobe Photoshop and photop.com. Um, we're going to talk about a new type of graphic or a different way of building graphics. Okay. And today's topic is going to talk about the concept of vector graphics, which is an entirely different way or a different method of building a digital graphic. So let's start with, I'm just going to use Photopea. It's faster for me to load. I'm just going to load up a raster image like this football here. And if I zoom in here, this picture of a football, this photo of a football is built out of, if I do out the math, this is 1200 by 1200. So there's about 1 million, 1.4 million roughly pixels in this photograph. Okay. And the way it works is that, each of these individual pixels can have its own color. And that is one way to build graphics, and there's pros and cons to that. It allows you to do very complex graphics, but it also typically leads to bigger file sizes, and there's some other, issues that can come up. So there's an alternative way of building graphics, which is called a vector. Okay. If the term vector kind of sounds familiar, you might have done this like in high school physics class, where a vector is a line that goes in a direction. So what I mean by that is, if you weren't watching me and I drew this line, I have a line here, right? But does it go left to right or does it go right to left? And the answer is you can't tell because there's no way to know that. But with a vector is a line or, it's a line that goes in a direction. In this case, my line goes from left to right. Okay. Or it could go right to left. So as you might have had the term vector in like a kind of like a high school physics class where it's like Billy goes 4 miles east, then he goes 2 miles south. What is the vector of Billy from his original location? Well, we can kind of take this idea a bit further, and if we keep building these vector lines, eventually we can create a closed shape, like a rectangle or a square or a circle or something along those lines. And this is the way that we can build graphics. So I could build like a rectangle, or maybe I'm going to build a triangle, so on and so on, right? And so the idea with vector graphics is rather than having individual squares, like those little pixels, if I was making a graphic of a face, maybe I would start with like, okay, there's a circle for the head, and there's some circles for the eyes, and, um, I have like this half circle for the mouth and so on and so on. And so rather than having 1.4 million pixels, I have four shapes. You know what I mean? All right. So vector graphics are defined as graphics built using paths created, created by mathematical formulas. Okay. So, you might think, why are we doing this? Didn't we just learn, Photoshop or Photopea? That seemed pretty good. Like, what's the point? Like, why bother with this? Okay. And the answer is, well, there are some benefits or some advantages to building something as a vector graphic as opposed to building as a raster graphic. So let's talk about that. Okay. I'm going to go to Photopea for a second. And let's pretend I had this photograph. Okay, let's say this image of this football was really small. Let me set it to exactly 100%. Okay, I think that's 100%. I'm going to blow this up from 200 by 200 to 2000 by 2000. Okay. And when I do that, you can literally see that the graphic has gotten very blurry. It's gotten very stair-steppy. Why did that happen? Well, that's because when I had my image as 200 by 200, I had 40,000 pixels, and then I blew it up to 2000 by 2000, which is 4 million pixels. So in other words, I had 40,000 pixels and now it's 4 million. So I literally added like, 3.6 million pixels. So the question kind of bears like, okay, where do those pixels come from, right? Do they just magically fall out of the sky? And the answer is most raster programs just take the original pixels and just copy them over and over and over. So every one pixel my original had, it basically times it out like 10 times. And the problem with that is the question, it's not gonna, the quality isn't going to look good. Okay. So that, if you have a raster image and you blow it up, like in terms of its size, there's and outside of using some sort of AI algorithm to help kind of generate some content, there's really no way to do it without it like looking poor. Okay. So that's kind of the problem with any raster graphic. It doesn't matter what raster program it is. It doesn't matter if it's Photoshop or Photopea or GIMP or whatever. You're going to have that problem. So, okay, what can we do? Well, in vector graphics, there are no pixels. That's a key point. There's no pixels. There's just mathematical formulas that generate a line. Like the lines I just showed you that look like that. Okay. And the thing about those formulas is if you don't, when you have a math, let's say I have a formula. Let's say I was drawing I don't know, let's say I'm drawing this shape here, this kind of blobby shape. All right. And let's just say for the sake of argument that that formula is X. Okay. As a mathematical formula because you can have formulas for circles and squares and all that kind of stuff. So if I wanted to make this twice its size, I could do 2x. Or if I wanted three times the size, I could do 3x or 4x or 10x or whatever. Okay. I could really just multiply it out. And so basically, what I'm trying to say is if you have a vector graphic, you can increase it as big or as small as you want, and it's never going to lose distortion. Because what was causing the distortion in Photoshop or Photopea or whatever was the pixels, and there are no pixels in a vector graphic that's going to cause that problem. So where could this be really useful? In real life, where this could be really useful is like graphics that are going to be resized many times. So, if you were a business and you have a logo, right? Like, think about the Starbucks logo or, the logo for any major company. It's like, well, where is that logo going to go? It's going to go on a business card, probably, right? I think that's about 3.5 inches by 2.5 inches. It's probably going to go on some letterhead. Maybe that's like, I don't know, 8.5 inches by, oops, 11 inches. Maybe it's going to go on the side of like a truck, like they're delivering stuff. I don't know how big that would be. I've never done anything of that size, but I don't know. It's probably like 2 or 3 feet by 2 or 3 feet, truck size. So 3 feet would be like, 36 inches by 36 inches, or I'm making it up, but it's a lot larger, is the point I'm trying to get across. So it's like, okay, if you took a graphic that was built out of pixels for 3.5 by that and blew it up to this, it's obviously going to cause distortion. You could go the other way around and make something really big and scale it down. That would technically work. But the problem, of course, is that like, well, then your files are these huge files, and it's, you know, not a great way to deal with that. So vector graphics could be a nice way to do this. So when we get to motion graphics, if you have graphics that are gonna, increase in size, or you want to make sure that, they never get distorted, even if they're enlarged beyond their normal size, a vector graphic is a good way to go with that, especially if it's a simple graphic, like a circle or a square or some sort of silhouette shape. Next thing is vector graphics have real curves. Okay. Let's go back to a raster program like Photopea. I'm going to zoom in here and I'm going to try to create a curve. Okay. So let's grab. Now, all raster programs use pixels. Pixels, by their very definition, are squares. So you can never really have like a true curve when you're dealing with a raster program like Photoshop or something along those lines, because you're always going to have this kind of awkward stair-steppy. I call it like Lego arches, because it's like in Legos you can never have like a really true curve because you're always dealing with squares, right? That's how Legos are. And it's kind of the same thing here. It's like you can never really have a true curve because you're always dealing with your building blocks, which are pixels, which are always squares. Okay. Once again, that's a pixel problem. And once again, as we said, there are no pixels in a vector graphic. There's just mathematical formulas. And you can have a mathematical formula for a, this wasn't a very good arch here or, curve, but if you had a curve, this would be a really good way of doing that, because you could actually, there is a formula for those curves there. So if you have a situation where, you want to have an actual true curve, doing it with vectors would be really useful. As kind of a side tangent here, I do sometimes, I mean, I haven't done it in a while, but I used to do a lot of laser cutting. And a laser can actually fall. The reason when I would set up my laser cuts, I would always use vectors as my graphic because I wanted it to get those nice sweeping curves. If you used a raster, you would get those little kind of stair steppiness, and that never ended up looking very good. So I liked having the true actual curve of a vector arch as opposed to one built out of pixels. I'm going to be honest, in this course, since everything we're doing is video based, that's less of a benefit, that particular benefit will not come up really, because at the end of the day, all of your graphics will be converted into pixels because computers and televisions use pixels. But if you were printing, or like I said, doing something like a laser cutter or something where you can where things don't have to be built out of pixels, they can use actual vector shapes, that might be a benefit to you. Finally, the last kind of major benefit is file size. Okay. So as I mentioned earlier in this video, oops. All right. In this image, the power of raster graphics is also kind of their downfall as it comes to file size. So what's nice about a raster graphic is you can literally highlight one pixel and I can move it anywhere I want, like that. That's pretty powerful. Now, that power comes at the cost of, okay, well, when a computer thinks about a raster graphic like a JPEG or a PSD or whatever, it has to calculate every pixel individually because every pixel technically is individual of each other. Every pixel can have its own color, you can move it, blah, blah, blah. And so, if I have 1200 pixels, like I said earlier, 1200 by 1200, my computer or the program has to think about 1.4 million pixels individually. And all of those pixels take up space, okay? And if I start adding in layers and all that other stuff, that starts adding even more pixels to my document, which makes my file size even bigger, okay? Once again, this whole problem here is pixels. Hopefully you're kind of seeing the underlying theme here. If there's no pixels, then, when we have a vector graphic, like I said, it's just built on mathematical formulas. All you're really doing at its core is building simple shapes out of lines that go in directions. I can build a triangle or a square or pentagon, whatever, so on and so on and so on. And the truth of the matter is, it's easy to store mathematical formulas, or at least not as much space as a raster graphic. So what does that mean? Well, what that really means is vector files will always be smaller file sizes to comparable raster files. So in other words, like if this was stored as a raster and a vector of the same dimensions, the vector will always be smaller in terms of its file size. Now, in 2026, is that really a big deal? The answer is maybe, maybe not. I mean, these days, we literally have thumb drives that can hold, multiple gigabytes worth of space. And so, the difference between a vector and a raster graphic being a couple megabytes here and there is less of an issue than maybe it was in the 90s and the early 2000s. Where it really does come into play, which is not going to really be in this course, is if you're dealing with graphics that have to be loaded really quickly. So if you were dealing with maybe a web development situation where people are constantly downloading your files, like your images, or maybe like a game or something where they're loading in graphics, if you were using vector graphics, though that loading would go quicker because the vector files are smaller. Or if something had to be downloaded from a server, like a website, if you've taken the 10 Digital 15 course, I strongly recommend that you do that. You'll learn all about servers and web design and that kind of stuff. Any file that's saved as a vector format, like an SVG, would always download much quicker than a comparable raster graphic, like a JPEG or a PNG or something like that. Okay? So those are just some basics when it comes to vectors. When we dealt with, I just kind of want to go over this real quick before we, splinter off. In this course, it's like I'm kind of letting you use, like with the raster, you could use Photopea or you could use Adobe Photoshop. Here, you can either use Adobe Illustrator as your vector tool or Figma. So any program that creates and edits vectors is a vector creation program. Of those, Adobe Illustrator and or sorry, not Adobe, but Figma would be some of the more popular ones. There are some other, Inkscape is a popular open source program. There's some others. CorelDRAW, is CorelDRAW? No, maybe not. There used to be something called Zeus. I don't know if it's still around. These are all vector editing software. There might be some other ones. Affinity Designer before they got bought had their own basic vectors. The way it kind of works, kind of like when we had raster editing programs like Photoshop and Photopea, and we had raster editing file or raster graphic files like JPEGs or PNGs or Photoshop documents. These are the applications. Typically, they save the files in common vector formats. A couple common vector formats. One is the AI. This is specifically for Adobe Illustrator. So if you're using Adobe Illustrator for this part of the course, I recommend saving as a .ai or working with AI. If you're not working with Adobe Illustrator, you're most likely not going to be able to open up that format because it's proprietary. It's owned by the Adobe Corporation. Some other formats you might work with that are vector-based are an EPS or an encapsulated PostScript and an SVG, which is called a scalable vector graphic. I know that Inkscape works with both of these. Figma works with SVGs. I don't know if it can work with an EPS, but it can work with an SVG. I haven't used Zoo, so I can't comment. But my point is really that If you have a program that is not Adobe based and you want to work with vector graphics, you're most likely going to have to use one of these. These are vector formats in that they save your graphics as mathematical formulas and they do not convert them into pixels the way that a raster graphic like a JPEG or a PNG or something along those lines would be. Okay. So in the next couple of videos, we kind of splinter and you can go whichever way you want to go. Vector, you can go Adobe Illustrator or you can go Figma, whichever, is easier for you. And then at the end, I will give homework that can either be done in either program. Okay.